Hi, my name is Veerle and I'm an R and Shiny developer. You're probably watching this video because you're a Shiny developer as well and you would like to learn how to optimize your Shiny application. One way to speed up your Shiny app and to make it more user-friendly is by using asynchronous programming. So the video of today is all about that. To give a bit of background, I was recently invited by Epsilon for the Shiny Gaterhings. When the meeting was there, it was a live broadcast. We were actually backstage joking a bit about the live coding gods because I was supposed to do some live coding during that gathering. Unfortunately, the gods weren't with me that day and I couldn't share my screen, and eventually we ended up with a big Q&A session instead of some live coding. But I thought it was a real shame because the live coding examples that I had prepared really showed you how to go from a normal synchronous Shiny application to an asynchronous one. And it didn't require a lot. It was just a few lines of code and all of a sudden you had an async program running. So I wanted to show you like that it isn't that daunting because often async programming in Shiny sounds very daunting and difficult and a lot of code involved and people don't understand it, but it doesn't have to be that way. Today I'm going to ignore the live coding gods and I'm just going to program pre-recorded. I'm going to discuss two examples with you for async programming in Shiny. One is using the crew package and the other one is using callr. So let's get started. First, it will be good to give a little bit of background about what async programming exactly is. And to understand that, it's first essential to know, what synchronous programming is. So let's start with that. Here you see an example of a program that runs 4 tasks synchronously. These 4 tasks all take a couple of seconds, and all these tasks are executed like they are in a queue. So one at a time. This means that this total program runs in 17 seconds, namely the sum of all the individual tasks. By default, if you're running a Shiny application, it works exactly like in the picture here. R is single-threaded and R by default runs one task after another. It can only do one thing at a time. And you can probably understand why this leads to implications in some Shiny apps. Because let's take a look at an example and let's put some users on here. Let's say that you have a Shiny app running, you have that deployed, and you have one session for that Shiny app. So one R session is running that Shiny application. You allow multiple connections on that single session, which means that you can have, let's say, 4 users using the application at the same time, using that single R session that can only do one thing at a time. So you see these 4 users, and the first person, he or she with the yellow background, is pushing a button that runs the tasks and takes 5 seconds. Now, if the second person, at the same time as the yellow person, kind of clicked the button to execute the task at the same time, that person has to wait 5 seconds plus the 4 seconds that it takes for this new task to execute. In total, this person, second person, has to wait 9 seconds. And of course, you can imagine how it will be for the fourth person. I mean, he or she is not very lucky because he or she has to wait for a very long time before his or her task gets executed. Basically, what's happening here, if you have multiple users doing a thing on a single R session, there is going to be a queue. And that queue is basically served on a first come, first serve basis. So it means that some users have to wait for a very long time. If you look at this example, you probably see that there are some smarter ways to execute tasks. So instead of executing them one after another, we can also execute them at the same time. This is asynchronously. Asynchronously means that we do tasks at a simultaneous time. So instead of that whole queue that we saw, we now see everything neatly under each other. This also means that this whole program of 4 tasks doesn't take 17 seconds to execute. No, it takes only 5 seconds, namely the maximum time that there was for the longest task that was there, which was 5 seconds in this example. This is much smarter. It's basically reorganizing how you are executing tasks. And because R by default doesn't do this, we need to have some code to actually make it happen like this. So if you look at our 4 users now, you will see that they will all be relatively happy. We can have a discussion about whether or not 5 seconds for a task is a bit long. That's not the point. The point is that this 4th person doesn't have to wait 17 seconds anymore. No, this person has to wait 5 seconds. This means that the app for the 4th person is definitely faster. However, this first person with the yellow background, in the first scenario, this person had to wait 5 seconds. In the second scenario, the user still has to wait 5 seconds. So asynchronous programming is not about speeding up your code. If you have code which takes 5 seconds to execute because it is doing a very lengthy calculation, or it is querying some databases, or it is calling an API, then using async programming is not magically going to make that 2 or 3 seconds. The task still stays 5 seconds. The only thing that we're doing with async programming is to make sure that R doesn't get held up by a big task that is there and doesn't form a queue. Basically, what we want with asynchronous programming is not have a queue at all. Constantly, we want our app to be available, to be responsive and free. And as soon as it needs to do a big task or a large operation, then we want to do it somewhere else. Still wait for it, for the results to return, but we want to do it somewhere else in a smarter way, nicely organized, multiple tasks at the same time. And we want to keep the main thread free. All right, we're all here for, of course, how we do this in Shiny. So there are numerous ways how we can do this in Shiny. And as I said in the intro, we have 2 examples that we're going to discuss today. But there are more than those 2 examples. I will briefly mention what is available. So we have multiple packages that can work for us when it comes to async programming in Shiny. The first is actually a combination of packages. It uses the future and the promises packages. It is most well known. And when you kind of hit Google and search for async programming in Shiny, you will end up with promises most likely. But there's more. There's also callr, which I'm going to discuss today. There's also something called callr, which is coroutines, and a package called crew. All right, let's first take a look at the base app, so the app that works synchronously. Before we're going to jump into the code, let's first see what the app looks like. So you'll see here this very beautiful styled Shiny application, which synchronously gets data from an API and gets some stock data. We have different inputs. We can select the company, we can select the date range, whatever we want. And we have some text output here. So here we see a status, namely there's no task submitted yet. And underneath that we see a clock. As you can see, that clock is running nicely every second, just as we expect a clock to run. It shows the system time and the system date. Now, that clock is important because I want you to pay attention to that clock. Because as soon as I hit this button, this get stock data button, we will see something happening to that clock. So I click it, and what we see is that the clock stops running. And besides that, we see that the status above that was turning gray. As soon as the data is fetched and it's ready, after 5 seconds, we will see the plot appear, we see the clock running again, and we see the status updated to done. So how does that work? Because we've seen that the clock is actually freezing as soon as I'm getting the stock data. So let's take a look at the code. First of all, we have our function, which is called run task, that retrieves the stock data from an API, from the Yahoo Finance API. Now, to call this API doesn't take a very long time. So to kind of simulate a long retrieval process and to demonstrate that you can actually see things being frozen, we simulate a long retrieval time with this system sleep function. A very advanced, complex calculation that is. As soon as we get the data from the URL, we do some parsing, we retrieve the prices, we retrieve the dates, and we make a plot out of it. A very simple ggplot, which we saw in the app. Then when we get to the UI, we see a very simple UI, a title panel, a sidebar layout, a main panel, some inputs. We see the text output that outputs the status. We see the text output that outputs the time. And of course, we have the plot. Then on the server side, we have some reactive values. One reactive value that stores the result, which is a ggplot, and one reactive value that stores the status. It starts off with no task submitted yet. That's the initial state of this reactive value. Then our outputs are being rendered. So our stock plot, our ggplot, gets triggered on this reactive result. And the status is also triggering on this reactive status. So about the clock function. The clock function makes use of invalidate later, which basically means I want to invalidate this code chunk every specified number of milliseconds. So in this case, every 1000 milliseconds, so 1 second, this code gets invalidated and the clock is being updated to display the exact time on the screen. What we've seen in the app live is that if this function runs and this takes 5 seconds to execute, then this code stops running. Because after all, this is a single R session and it can only do one thing at a time. And when it's busy with this, yeah, it can do this. So that's why it's freezing. You will also see that, it first updates this as we expect, then it runs the function, then it updates the status to done. So it's all in a queue. It's kind of row by row, it executes what it needs to execute. So this is normally what we see in every single R script that we develop, one thing after each other. Obviously, there are some smarter ways to do that, and that's exactly what this is all about. So first of all, I'm going to show you how to do this with the crew package. So probably you haven't heard of crew before. So let's first dive into what crew actually is. The crew package is actually a package built on top of another package called Mirai. Mirai, and I don't know if I pronounced it correctly, is actually Japanese for future. What Mirai is basically a way to schedule tasks in an R session. And Mirai is actually great because it is very minimalistic. It has a very tiny R code base and it almost has no dependencies. It only relies on NanoNext, which I'm not going to go into detail on that, but it relies solely on NanoNext, which is basically a messaging protocol to keep track of all kinds of tasks that are running on a computer. The crew package was built on top of Mirai to kind of provide a nice interface around scheduling all those tasks and managing all those different things. Because essentially what we're going to do when we're going to program asynchronously is we're going to keep the main thread, so the thread where the Shiny app is running, we're going to keep that free. We're going to make sure that the clock keeps running, while at the same time the tasks we're going to send up somewhere else, so another R session. Of course, if you're going to spin up other R sessions that need to communicate with the main thread, there is some messaging involved and some complexities, and that's why we have these nice packages that solve that for us. So the crew package, I discovered it recently. I haven't heard of it before, but I think it's great. The interface is very clean, and that's exactly what I'm going to show you. Back to our code. So first of all, we need to make some changes. So what I'm going to do, I'm just going to create a new R script and I'm going to put all of this into another script so that it's nice and tidy. All right, the first thing, of course, that we need to do is to load the crew library. Makes sense. Then we're not going to do anything about the function. That remains the run task function, keeps spinning 5 seconds. We're not going to touch that. The UI we're also not going to touch. There's nothing there. The only thing that we can actually do, well, we're not going to call an API synchronously anymore. We're going to call it asynchronously and get AX stock data. And to make it a bit nicer, I'm going to add a nice rocket to that because that's my favorite emoji. All right, first we need to do something about the reactive values because we need some extra setup here. First of all, what I want to introduce is a reactive poll. This is basically a reactive value, reactive val with a value of false. Basically, the reactive poll is kind of keeping track of whether or not it is still busy with fetching or executing tasks that are somewhere else. It kind of helps us as a flag of, hey, it's ready now, or hey, it's not ready yet. Okay. So we have the output here. What we also need now is we need to set up a controller. So we're going to set up a crew controller. Basically, what crew allows you to do is to kind of set up a manager or a controller that is keeping track of all those separate tasks that you're going to execute. So what we're going to do is we're going to assign something that's called controller, and we're going to use the crew controller local function, typo, local function, and then we have some options that we can set. So we can, for example, say we want to have 4 workers, and then we have also some options like how many seconds do we want things to be idle. So after how many seconds are we going to shut down a worker if the worker doesn't have anything to do? By default, I believe it's 10 seconds, so let's go for that as well. So that is our controller class. And what we're then going to do is, makes sense, we're going to start it. So controller start. All right, so that's our controller. Then, of course, we need to use it somewhere. So if we click the button, our task will be executed. Now we have to push that task to a controller. So as I'm already saying here, it makes sense then to do something like controller. I want to push something now. And in the push function, you have different arguments you can give. The most important one is the command you want to run. So what kind of code do you want to push to the controller, to one of the 4 workers that you have there? So the command is basically, again, run task. That's our function, what was called. Then we have with a symbol, with a start date, and with an end date. The thing to realize, and it's important, the thing that you need to realize here is that if you are spinning up an R session somewhere else, then this R session doesn't know anything about the main thread. It means it is a blank R session. It hasn't got any libraries loaded or whatsoever. So you need to tell that. You need to tell the controller here, okay, I want to push this task, and for this task to run, I need this environment. So also, if you have a reactive value or somewhere in your Shiny app and you think, oh, I'm just going to magically assume, or a global variable, I'm going to magically assume that is known to that child process, then that's not going to work. It is a blank R process, and you have to realize that every task you're sending there, it is going to require some setup for the task to actually be able to run. So what we need is kind of a data. We need to specify what data to give with that task. So that we do in a list format. And what we need to do then is here explicitly say, okay, we have an object that is called run task, and in this case, that is our function run task. We have an object called symbol, which is input symbol or company, I believe. So the symbol is actually the ticker of the stock. So all these things that we're specifying here in the command, so what is the run task, what is symbol, what is start date, what is end date, we need to provide that in this data argument. So we have the start date. The start date is, let me look here, that is input dates 1. We have the end date is input dates 2. So basically, here we specified that symbol is input company, start date is input date. We now do the same only in the data argument. So this doesn't look too daunting yet. Then what we're missing here is, of course, the libraries that we will need, because if we're looking back at our run task function, which was here, we will see that we have some libraries. Get comes from the HTTR package, from JSON comes from the JSON Lite package, and of course we have ggplot. So that means that when we are going to push, besides the data, we also need to provide an argument which is called packages. And then we can just say we need HTTR, we need JSON Lite, we need ggplot too. I'm going to delete this because this is old and synchronous. So now we have a controller and we're going to push that to that controller, to one of those 4 workers. Yeah. What I also want to do here is set this reactive pool, reactive val that we specified earlier. I want to set it to true. Because what this means is I'm going to push the button. I'm going to update the status to running. Then I'm going to push my task to the controller, which takes a split second. This doesn't take 5 seconds to execute anymore. Now we're going to push it somewhere else. As soon as I've pushed it, the R session is free again to do whatever I want. So I'm going to set this reactive poll to true to kind of tell me, okay, I've pushed something now. This we don't need here. So we now have this reactive poll value to true. So what we can do with that is kind of build and observe code chunk. And we can say, okay, I want to watch out for this reactive poll. So I want this code to trigger based on that. If that is true. So if that is true, the reactive poll is true, which I set here to true. I want to invalidate this piece of code. Of course, that only happens once. So what I want to do here is as soon as I pushed the task to the controller, I want to validate every, let's say, 100 seconds, 100 milliseconds, that is. 100 seconds would be a long time. I want to check every 100 seconds if it's done already. So I want to reiterate over this code over and over again, every 100 milliseconds, and that's why I'm putting that in there. And I want to check for the result. So what we can do here is we can call our controller again. We can pop, meaning check what it is, and we can ask for the result. Then we can do something like if so if is false, controller non-empty. So basically this controller object has a lot of methods to it because the crew package is using R6. It has a lot of methods to it where you can kind of ask for information, different kinds of information. So we can ask here for the non-empty method, which means that we basically want to check for this controller, is it non-empty? So is it ready? So if this is true, if this is false, yeah, then it's ready. And if it's ready, we can update the reactive status to done with a nice check mark. There. We can update the reactive status to done, and we can also set the reactive poll again to the value of this controller non-empty thingy. So if it is done, if there are no tasks in the controller anymore, so it executed all the tasks that were pushed there, then we're going to update the status to done. We're going to set this reactive poll, reactive val to false again. And of course, we need to retrieve the results. So the result is in this result object, or is supposed to be in this result object. It depends, of course, whenever the process is ready. So this will be null if there's no result yet. So if the task is not ready yet. So if this basically is not null, the result, then it means that the results are ready, and then we can update our reactive result which stores our ggplot. We can call it like that. It is important to realize that the results are coming back to you in a list. So that's why we're requesting here the first element of the list to go, which is our ggplot then, to go into the results. So we need to see if it works. So we're going to save our app. We just call this the crew app. Save it, and we try to run it. First, stop the old app and see if that works. So we're seeing the same app here. There's no difference here. We didn't do anything about the UI after all. We see the clock running, but what we would expect to see now is that if we click get stop data, that the clock keeps running. So let's see if that actually works. If we click that, we now see that indeed the clock is running, although it jumped a little bit. We see nothing freezing, nothing is stalling, and once it's finished, it's displaying the result. So this is very different from the first base app that we saw, because that was not a good user experience. It froze completely. And in this case, when we now are calling the API asynchronously, we actually calling the API in another process. And this means that the main process, which is running the Shiny app, can do whatever it wants to do. So no more freezing, no more unexpected behavior from an app, and no more longer waiting. And this also means that if there are 4 people on this app pushing that button after each other, then there's also no real issue there, because we have 4 workers specified. We can, if there are 4 people on there, we can send all those tasks. Crew takes care of that. We can send those tasks to these 4 workers, and nobody has to wait 17 seconds anymore for the data to be retrieved. Perfect. The second example is all about callr. So let's first take a brief look about what callr actually is. Callr is, as the name suggests, it is callr from R. So what this does is, if you have a Shiny app running on a current R process, you can use callr to spin up a separate background R process, which runs somewhere else, and you can send tasks to that. It is very similar to how crew operates, or basically any asynchronous program operates. It is going to keep the main thread with Shiny on it free, and it's going to execute tasks somewhere else. So the essence of the package is very similar to the crew plus Mirai solution. Only the syntax here differs. So let's take a look at how that actually is working in the Shiny app. Back to our base app. This time we are going to make a separate script with a callr application. So we copy the code, and we're going to change this code into a asynchronous app. Function remains the same. We're not going to do anything about that. Instead of the crew package, we're going to add here the callr package. And again, we're going to change the title, because now we are calling the API asynchronously. With a work again. All right, where to start? Let's start at the server side. On the server side, we will need, again, some new reactive values who are going to keep track of everything that's happening. And here we need a little bit more reactive values. So we're going to go back to our reactive poll. So the reactive poll, again, here is used as kind of a flag that tells us whether or not something is busy or not. The reactive poll is false here as well. Then we also have another reactive value, which we call background progress. So we can call it background process abbreviation, and that's also going to be a reactive value with the value null. So basically what this reactive value is going to do, it is going to store the results of the background process. So nothing changes on the stock plot, nothing changes on the status, also nothing changes on the time, but something is going to change here, namely where we click the button of get tasks. So again, whenever we click the button, we're going to update the status to running. This code is going to change. We don't need it anymore. Instead, we're going to set up a process. This process we call a P, just for simplicity. And we're going to call the function from callr, which is our background. The R background function, our BG function, takes a couple of arguments. The first one is the function going to run. Note that this is very similar to the crew example that we saw. So we have a function argument. In that function argument, we basically give a function, as the name suggests. So we generate the function here, and this function is going to take some arguments, so things that we're going to give to this background process. For one thing, that's our function, that is our symbol, that is our start date, and our end date. All the things we need to run our background tasks. So that's function. We're going to do something with that. And basically what we're going to do in this function is see it as the script we're sending off to the other background process. So what we're doing here, instead of crew, we're going to specify the libraries here. So we need HTTR, we need JSONLite, and we need ggplot2 for the plot. And then we need to obviously return something, which is the results of our run task function. So run task, which was a function with the arguments symbol, start, date, end date. All of them. So the R code on its own here is not very complicated. It's just we want to run a task. The task has some arguments. And basically, we need to specify it all twice here. So it's a function within a function in this case. Then we have an argument which we call supervised true. We can set it to true if we want to keep track of what the process is doing. And in a Shiny app, that is kind of nice if we do it like that. And we need to give the arguments. So this is basically the same as the data argument that we saw in crew, only now it's called arguments. This again is a list, and we need to specify again here that what this run task function, where that is coming from. So basically we're passing from the environment of the Shiny app, we're passing it to the child process, the background process. So our start date is then input. I can actually do that much quicker. I can type very fast, but this is just a little bit quicker. We need to give our arguments here, like this. And that is kind of our P, our object P. What we then want to do, so this we don't need anymore, that's old. We also don't want to immediately display done because it is not done immediately. We want to update our BG process reactive value that we set in the beginning. And we want to store this P object in here, this process object, what it's supposed to be returning. At first, when this immediately runs, this P object is just a promise, something that will happen in the future and something that in the future will be populated with something, but there's nothing there yet. So it's a promise. We're going to update that. We're going to set a reactive poll to true because now we're going to, we kicked off the function. Now we want to monitor it and see when it's ready. And our reactive status is updated there. All right, so what do we need to do here now? So the first thing that we need to do is we need to create an observe chunk. And we're going to basically listen for a change in this reactive poll. So whenever this reactive poll is true, so if this code did execute, we want to call this observe, and we want to run some things here. What we want to do here again is invalidate later. We can do it every 100 milliseconds again. And every 100 milliseconds, we basically want to check, is that process, is that ready? So is that ready? And if it's ready, I want to store it in P again. All right, so this P, again, has some methods to it. It has some characteristics that we can query. So this process, we can, for example, the one thing that we can ask, is it alive? Meaning, is it still, busy? And if it's not alive, So if it's false, then apparently it's done, because that's the thing. You can change it in callr if you want, but by default, the process is spun up and is kind of killed whenever it's done doing what it was supposed to do. So if it's not alive anymore, then that means that the results are ready and that I can update the status, the reactive status, because then we're done with a nice check mark, and I can get the results, the plot as well. So I can set the reactive poll to false again, because we're now done. We don't have to evaluate this anymore every 100 milliseconds. And I'm also going to set the background process to 0, because we're basically resetting these values here. This we need to do so that we can click on the button 2 times after each other. And we need, of course, the results. So where are the results actually in this object? So we want to have the reactive results, and they are actually also in the P object, and there's a nice method which is just called get results. And that is going to store the results in it. All right. Again, we're going to save this, and now we call it a how original the callr app. And we're going to see if it runs. A very quick check if I've got everything that I needed. Let's see it. So again, same app. The clock is running. What we don't want to see is this clock freezing. So let's see that if we hit the button, that indeed the clock keeps ticking. As you can see, that's the case. We're running now, and we have to wait 5 seconds-ish, and then we have an error. That always happens. And as I can see, that's because of a typo. Reactive results, it's a reactive result. You will always see that. Let's try again. So 5 seconds-ish again, fingers crossed. And another one. Error enforce, attempt to apply a non-function, line 108. So this P get results is also wrong. Somehow I like the word results better than result. It's a single one. It's not results. It is one single result that we're retrieving. Again, we try. See if it's working now. And on to the next error. Argument symbol is missing. That makes sense because I didn't specify that. Symbol is actually input company. You see how that goes. No matter how long you're programming, whether that's years or you're just getting started, this is completely normal and can actually happen 1,000 times a day. No shame in that. Again, and now we see the results displaying on the screen, which is very nice. So as you can see, it was a bit of a different process compared to crew. And if I am looking at my personal preferences, I just discovered crew. So then we're actually talking about a couple of weeks ago. I encountered it somewhere when looking up something about asynchronous programming. And I was like, oh, wow, this is really cool. A really nice interface. I used to be on the callr camp, so to say. I was using callr, and because it made sense to me. It was pretty clear what was happening. It was just as simple as, okay, if this happens, if I push this button, then I want to set up a background process. It was as simple as that. It's not very complicated, doesn't require deep thinking whatsoever. It's just, I have a task, I want to have it executed somewhere else, do that. I need to give it a function. Yes, you need to play around with some arguments and what seems like double coding. But if you don't think about it, like this R session that I'm going to spin up is completely clean, it doesn't know anything. Then, you know, after a couple of attempts, you are getting the hang of it. So this made sense to me. That was actually when I saw crew, then I was like, oh, this is actually even more clean, because somehow this requires just a little bit more code. The essence and the theory behind it is the same, but it requires just a little bit more code. And I think the crew package especially has a lot of options. So for example, you can set the number of workers that you want. You can also keep these background processes persistent, meaning that you don't want to shut them down, meaning that you can reuse them as more users come along and more users start doing things in your app. And I think that is really cool. Plus, the crew also supports remote workers, meaning that you can say, hey, I have a Kubernetes cluster somewhere, or I have this other machine, an other virtual machine that can handle tasks for me. You can simply specify that in crew. And in callr, I'm not sure, but it might be more limited. So personally, I would say give crew a go. I think it's fantastic. And I hope I showed you today that it's also very easy to make your base app into a crew application. I hope today you learned something about async programming in Shiny. I showed you two ways of doing it, of transforming a synchronous base app into an asynchronous application by using the crew package and by using callr. As I said, my preference really now as it is, I have a little bit of love for the crew package just because it is so easy to use and the syntax makes sense to me. But compared to other async packages that are out there, I think these two are definitely on highest on my list, because as you are a beginner, it's much easier to visualize, hey, I have a task and I want to send it somewhere else, than it is to work with kind of promises objects and not being sure what happens. Here, the syntax is very clear. The code just tells, hey, I just hit this button. Now I want to either push this or I want to set up a background process. For me, that just makes a little bit more sense, and I hope it does for you now too. If you want to take a look at the code that was used in this video, you can take a look at the Async Shiny repo on GitHub. In this repo, there are multiple examples of how to implement asynchronous programming in Shiny. Please feel free to add examples here or to make suggestions. I really hope you like this video. This is my first YouTube video ever, and perhaps if you like videos like these, I can make more in the future. Just let me know, give a comment or give a like, and give me a follow if you want to see more in the future. Thanks for watching.